Solving proportions. Now, this is an important concept. This is one of those concepts that I really love teaching, so it makes me extra sad that we're not in school to learn it. But it's one of those topics that I rarely get asked, when are we ever going to use this? A lot of the questions you'll see, you could probably see yourself in the scenario using them. Solving proportions we use for scale drawings, using maps. We use it for sales tax and discount. We use it for scaling up and scaling down. And you'll see a lot of real life applications to proportions. So this is an important one. Edmentum explains a really funky way to solving proportions the first time. Then they get into cross multiplying. We are going to use cross multiplying to solve. Now the key is not the cross multiplying. That's easy. It's the setup. The key to setup, as always, which you've heard me say, is to be consistent. And if we're consistent, which means we do the same thing on both sides of our fraction and in our proportion, same thing on this side as we have on that side, which helps with labeling, then you should be just fine. So it's important to be consistent, and then we will cross multiply and divide. You may recall that a ratio is a comparison of two numbers by division. And we see a ratio written in three ways. The way that we're going to use most often is as a fraction. So when we deal with two ratios that may be equivalent, for example, 6 to 8 and 8 to 24, to determine if they're equivalent, we can simply set that ratio in fraction form next to that ratio in fraction form and compare them. There are several ways to compare to determine if they are equivalent relationships. One of which is just to simplify each of these fractions, one of which is to turn each side into a decimal, but the way that we really want to lock in is to cross multiply. It is a fact that if they are equivalent, when you cross multiply, in other words, it's only when there's an equal sign in the middle, you multiply the numerator of one times the denominator of the other, and vice versa. When you do that, you'll get 144 on one side, 144 on the other. So the cross product of course means multiplication, in two equivalent ratios, the cross product is equal. When they are equal, that is the definition of a proportion. A proportion is two fractions that are equal to each other, two ratios that are equal to each other. So if it tells you that it's a proportion, that means that the cross products are equal. We could use that information to help us find one of the missing numbers if there is a missing number. As I just mentioned, if two ratios are equivalent, two fractions are equivalent, you cross multiply, and if their cross product is equal, then it is a proportion. So to determine if they're equivalent, all you have to do is cross multiply. 2 times 18, that's 36. 9 times 4, that's also 36. So if I had 9 over 2 is equal to 18 over 4, this would be a proportion because the cross products are equal. They divide to be the same number, 4.5 and 4.5, but the cross product thing is what we want to pay attention to for today. This is an example of a proportion. You see this basic proportion all the time. You probably saw it in Edmentum. Here's another example of a proportion with numbers. We know that 4/5 is equal to 8/10 because if you think about it, if you double 5, that's 10. If you double 4, that's 8. That's the same thing we've been dealing with. Like if I put this stuff into a table, you could see 4, 5, 8, 10, 12, 15. Those are all the same relationships. So we just took 2 out of the possibly 4, 5, 6 amount of fractions, and that's what a proportion is. Of course, you won't always be given all the values. Sometimes one of the values is going to be missing. There are several ways to do this, but the way that you really need to pay attention to is that if you cross multiply 10 times 12, that's 120, is equal to 8 times x or 8x. This is really a one-step equation, right? Where one of the variable on the right, x, has been multiplied by 8. So I split down the middle, divide by 8, divide by 8, we get x is equal to 15. So in this case, it's 15, which we kind of knew from the previous page. I just showed you is 10 over 15. That's kind of the long way. The short way is just to do what's called cross multiply and divide. You still need to make your loops to help you know. You cross multiply the two numbers that you can and then divide by a third. I'm not a huge fan of teaching it that way, but in this quick virtual learning situation we're finding ourselves in, it's the most efficient way for you to understand how to do this. We cross multiply, then divide. So if you look at this example, we do 10 times 6. Those are the two numbers that we can actually do. 10 times 6 is 60. The third number that's left is 12. Divide by 12. 5 is what x is equal to. It's cross multiplying and dividing. If you don't believe me, we can plug in 5 to where x was and see if it in fact works. If I were to put 5 where x is, 10 times 6 is 60. 5 times 12 is 60. You also could see that if I just went from 6 to 12, that's times 2. Over there is times 2 also. That quick trick is called an in-between. That will also work. Like if you're able to figure out to go from 6 to 12 is times 2. That's also, it only works with multiplying and dividing. It doesn't work with adding, or so you can't go, oh, that's plus 6, so I'll plus 6. That's not how it works. It only works by multiplying and dividing. Example down here, you could just do a quick cross multiply. So 5 times 30 are the ones you could do. 5 times 30 is 150. 10 is the leftover. Divide by 10. That's, of course, 15. Therefore, the missing value of x is 15. If you wanted to do it that quick trick way, and you kind of like what I showed you at the end, you could see that from 5 to 10 is times 2. So what times 2 is 30? Well, 15 times 2 is 30. One more example. 5 times 10.5 is 52 and a half. And then 7 times m, well, we wouldn't do that part. We divide by the leftover 7, so we get m, not x in this case. We get m is equal to 7 and a half. Is it possible to get decimal answers? You bet it is. I had to use my calculator for that one. Hopefully at this point you've found some practice that you can do. Just doing some regular solving proportions. We're going to do some more solving proportions, which is the easy part once you have the setup. As written on the screen right now, proportions are very powerful tools if you know how to use them. It solves many word problems, but the key is the setup. The rest of it, the cross multiplying and dividing part, is pretty easy. It's very straightforward. It's the same thing every single time. It's the setup. If you can set it up properly, then you should be able to solve it properly too. One of the suggestions I'm going to give you is to label your units. Label. If you label, it will help you to be consistent. When I say consistent, I mean if you put feet on top on the left, you have to put feet on top on the right. Consistency means doing the same thing. So it'd be inconsistent if, let's say in class, I gave one kid a lot of homework, but not a lot of homework to another kid. That would be inconsistent. If everyone got the same, that would be me being consistent. So consistency allows us to set up a proportion. In a proportion, there are 1, 2, 3, 4 blank spaces. We are going to be given 3 out of those 4. You're going to be asked to find the last of those 4. So if you notice in this example, there are 1, 2, 3 numbers. It says Costco is selling calculators for the reasonable price of $25.50 for 2 pounds. If Miss Scales wants to buy 7 pounds of calculators, how much will it cost? It doesn't really matter which one you put on top, pounds or dollars. It doesn't matter which one you put on the left or which one you put on the right, again, as long as you're consistent. I would make the suggestion that dollars should almost always go on top. We talked about that in another video. So I'm going to put $25.50 on the top. Which one should I put it on? Should I put it over here or should I put it over here? It doesn't matter. I'm going to put it over here just because I think that some of you wanted to put it on the left. Now I'm going to label with dollars because I want to make sure that I don't put something where it doesn't need to be, and I want to remember that $25.50 is my dollars. Now I have 2 pounds and 7 pounds. Both of them are going to go on the bottom because I have open spaces on the bottom here and the bottom there. So I want to make sure that I'm consistent. Now the 2 pounds. Does the 2 pounds go on over here or does the 2 pounds go over here? In order to be consistent, the 2 pounds matches up with the 2550. So I put 2 pounds here. Be careful. Don't think that's a 21. It's 2 pounds by putting 2550 along with the 2. If I put the 2 here, I know what you're thinking. You might think, well, I'm going to cross multiply them. No, we're just setting up right now. 2550 attaches to the 2. Now, to be consistent, the 7 pounds, should the 7 pounds go up here? No, of course not. The 7 pounds would not go up there because that would be inconsistent. Since pounds are on the bottom on this side, I got to put 7 pounds, 7 orbs on that side. What goes over here? I don't know what we're looking for. That's the X. That's just the setup, and once we have that done, it's just simple cross multiplying from here. 7 times 2550. You'll certainly need a calculator for one like that. 7 times 2550 is 178.5. And then the leftover is 2, not 21, because that's 2 pounds. So then we divide by 2, and we get an answer of 89.25. Now, that's not the true answer because it doesn't have a label. Remember, we're looking for the number up top, which is labeled the dollars, so the price is $89.25 for 7 pounds. I'm going to do a couple more examples, but I'm not going to actually solve. I'm just going to help you with this setup. Again, a proportion. We should understand there's a proportion because it kind of follows the same format if you read the questions. In the first 10 minutes of a volleyball match, Gracie hits the ball 7 times. If things continue at this rate, how many times will she hit the ball if the match lasts for 55 minutes? 10 is to 7, as blank. It just kind of fits. This is to this, as that is to that. So we know in a proportion there are 2 things that are kind of matched up. In this situation, it's 10 minutes, 7 times, and then 55 minutes. So you can still see that there are 2 numbers that are automatically connected in proportion. Again, in proportion, there are 4 blank spaces, 1, 2, 3, 4. And there are always going to be 2 numbers that are automatically connected. Those 2 numbers that are automatically connected go together in one of the 2 sides. They can either go on the right or they can go on the left. It doesn't really matter as long as you're consistent when you put them in there. So the 2 numbers that are connected are in this sentence together. In the first 10 minutes of a volleyball match, Gracie hits the ball 7 times. I know you might think that the 10 minutes and 55 minutes are connected. They're just labeled the same as both minutes. They're not connected. This is the situation that's connected. First 10 minutes, hits the ball 7 times. So those either go on the left or they go on the right. It doesn't really matter. And it doesn't matter which one's on top. For this particular example, I'm going to put the minutes on top. Now, on the last one I did on the right side, I'm going to do it on the left side just to show you 10, and I'm going to label minutes so I know, and then the 7 hits. Now, I have a third piece of information that's 55 minutes. If I were to put 55 minutes on the bottom, this would not work because I'm not being consistent. Again, consistent means do the same thing. I put minutes on the top and the left, and this time I'm not putting minutes on top. You have to put the same thing on top. Therefore, if I put minutes on the top on the left, I have to put minutes on top on the right. And then to solve this, I would cross multiply 7 times 55, and I would divide by 10 and get my final answer. This one down here is a word problem. When you see a word problem, particularly one that involves an actual physical action or a physical thing, in this case a tree, you're going to want to try to draw a picture. So let's read this question. A tree casts a shadow that's 7 meters long. At the same time, a nearby building casts a shadow that's 21 meters long. To the nearest meter, what's the height of the tree? So we're talking about shadows and trees. Let's draw the tree. Here's my tree. I'm going to draw a purple tree. Here's my grass. And then it's got a little shadow. And then I've also got a nearby building. And this building also casts a shadow. There's the shadow of the tree, of the building, excuse me. So a tree casts a shadow that's 9 meters long. At the same time, meters. At the same time, a building which is 54 meters tall casts a shadow that's 21 meters long. How tall is the tree? Now, as you can see, this is the thing that we're looking for. When I draw this picture, my proportion sort of sets itself up. And I can plug in from here. If you notice, you can put x over 9, and then over this one is 54 over 21. Then we're in a cross-multiplying phase. And we don't have to cross-multiply necessarily in this example because it is multiple choice, and we can sort of see what we think the answer is. Do you notice how the building is taller than the shadow? That means the tree has to be longer than the shadow. So could the answer be 4? No, because that's shorter than the shadow. You also might notice that 21 to 54 is a little more than double, right? If I double 21, it'd be 42, which is a little short. So if I double this, it'd be 18. I want to be a little bit more than 18. Well, this is exactly 18, so that's not enough. 23 fits, but let's check our other answer. 126? That's way too tall. That's taller than the building itself. So the answer is clearly C. That's what you would have gotten if you cross-multiplied and divided. You would have gotten 23 meters. Let's do one last example. And one thing I want to show you is how I could have set this up multiple ways, but I still would have gotten the same answer. All right, again, Kevin mixes paint using 8 ounces of yellow paint for every 3 ounces of white paint. At this rate, how many ounces of white paint will be mixed with 24 ounces of yellow paint? Let's set up my proportion. There are two numbers that are automatically connected. In this case, it's right in this sentence. 8 ounces of yellow for 3 ounces of white. So 8 ounces of yellow for 3 ounces of white. Now, I quickly made this decision. I could have asked you, but I quickly made the decision to put 8 ounces on the top and 3 ounces on the bottom. There's a third piece of information, 24 ounces of yellow. To be consistent, will it go on the top or the bottom? Well, since yellow is on the top, we have to put yellow on the top again. Therefore, we would put 24 ounces of yellow, and we're looking for how many ounces of white. You could cross multiply. You also might notice that from 8 to 24, that's times 3. So this is also times 3. Therefore, the answer ends up being choice G, or 9. Now, what if I had set up this problem completely differently, and I did not want to have 8 on top, 3 on bottom? Maybe I completely mixed this around and did a totally different way. Would I still get the same answer? You should. So let's still deal with 8 ounces of paint for 3 ounces of white. And this time, let's say I put the 3 ounces of white here and the 8 ounces of yellow down there. Now, to be consistent, the 24 ounces of yellow, looking at this example, is now on the bottom. 24 ounces of yellow, X on top. We still go from there to there is times 3. It's still times 3. There are multiple ways to set this up. As a matter of fact, you could have done something like this. 8 ounces of yellow matches up with 3 ounces of white. You could do this. I'm not a huge fan of doing it this way, but you could. Now, knowing that, 24 ounces of yellow, do you think it's going to go here or here? Well, 24 ounces of yellow, again, being consistent, since yellow is on the left side, we'll put 24 ounces of yellow there, and we're looking for that. All right. If we were to cross multiply 24 times 3, we get 72. And then the leftover, which is 8, we divide that by 8. And of course, 72 divided by 8 is still 9. I'm just trying to show you that there are multiple ways to set it up. But as long as you're consistent, you should end up with the same answer, which is hopefully the correct answer.